All right, this is the Geometry Unit 3, Lesson 5 video, all about looking at the slope of lines. So this should be familiar to all of you since you've already taken an algebra course. But what we're doing is just kind of reviewing this concept because it relates to dealing with like angles and how the angle of a slope relates to the value of the slope that we learned when you first did this in algebra. So just to kind of give an overview, the slope of a line refers to the difference between how much the line goes across in relationship to how much it goes up. So we call this the rise. We call this the run. And the value for the slope is the rise divided by the run. Mathematically, that also can be known as the change in y over the change in x. And then, of course, breaking that down even further, if we take 2 points, let's call this point 1 and point 2. Okay, call this point 1 and point 2. If this is what we call x1, y1, call this x2, y2. Sorry about that. It's kind of a mess. The formula for slope is y2 minus y1 over x2 minus x1. So these are all different ways to think about the same concept. And that concept is if we compare how far this has changed in the horizontal direction versus how far it's changing in the vertical direction, we can do that just by counting, or we can do that by actually calculating the value. That gives us the slope. And so that's generally speaking what we're kind of covering in this lesson. And they kind of approach it in a few different ways. The first is in terms of like a percent slope. So a percent slope would be like what you call a grade. Like it's saying like what is the ratio between the rise and the run. So in this picture of the skier, you have a run value of 100 feet and a rise value. Let me erase that real quick. You have a run value of 100 feet and a rise value of 40 feet. And so we make a comparison and we do rise over run, 40 divided by 100. We get 0.40, which converted into percent is 40%. And so that would be one way to talk about that slope. That's why they say here that it says has a slope of 40%. So the first thing you're going to have in this is you're going to have some questions like that. So let me just roll down here real quick, just show you. That's like number 4. Number 5, I would say draw a picture of what you're being described. In this one, they give you the slope and then give you the rise, and you need to figure out the run so that it makes a 50% slope. In other words, the rise divided by the run gives you 50%, or 0.50. What's the slope of a surface having a rise of 5 feet and a run of 0 feet? Okay, 0. And that kind of brings us to the first kind of like one of the other major concepts in this lesson, which is just some basic concepts around slope. And one of those is that you need to know, just looking at a line or looking at some of the values for the rise and run, whether a line is a positive, negative, 0, or what we call undefined slope. And you see those images right here. A positive slope, you can see always kind of goes up as it moves across the graph from left to right. Negative slopes, you can see here, move down as we go across the graph from left to right. So positive, negative, 0 slopes are straight horizontal lines across the graph. They don't go up or down. They have a 0 slope. And then undefined slopes are lines where the slope, where it's not a slope across, it's only up and down, it's only vertical. So you need to know the information in this table. And you'll see the last question in the lesson is going to ask that exact question. Choose which slope is positive, negative, 0, or undefined. So that's one main concept that you need to have. And then what I'm going to do is I'm going to do examples of each of the other types of problems. Like in number 6, they say find the slope of AB. So let's say I get here and they give me the following. We'll call this point A, we'll call this point B. And they say there's a line going through this. Actually, I'm going to pause for a second and I'm going to do this differently because I want to draw using, yes. Okay, here we go. So let's say we get this point and this point. That's going to be a little bit better. And so we have this here. This is my line. This is point A and this is point B. And they want us to tell them what the slope of the line is. So my recommendation to you for the most part on these is I don't think you need to go through the process of finding the actual slope using the formula, because I think that's great and all, but really counting is going to be the best way. So if you make a little triangle out of the line that goes across for the run and up for the rise, and you can see here this line goes over and then up like this, and then you count the spaces on those. So here we have like 1, 2, 3, 4. So this has a run of 4 and a rise of 1, 2, 3, a rise of 3. So then the rise over run is 3 over 4. And so that would be the answer for this line. And that's basically what they're having you do in number 6, find the slope. So you need to count the spaces, and they don't have a grid, but you can still do it. You can count the spaces and then count the spaces for the rise and run, do rise divided by run, and calculate the slope that way. Then they do something a little bit differently. Then they're going to give us a line information, and they're going to tell us, okay, you have this point. Let's call this point, well, I wanted to draw on that. So there we go. Let's say you have a point here, and they say you have a slope of negative 2/3. And they say, what other point could be on this line? So if negative 2/3 is my slope, that means that this line is going to rise, or in this case go down 2 because it's negative, and run 3. So if that's the case, I can easily just count the spaces from one to the next. So if this is already one of my points, we'll call that point A. And I want to go down 2, 1, 2, over 3. 1, 2, 3. There's a new point right there because it went down 2 over 3. Down 2 over 3. And that gives me a new point. And that point has a coordinate of 1, 2, 3, 4, 5, 6, comma 4. I could go again. Down 2 over 3. There's another point right there. And that's the point 9, 2. And you can see you can continue to do that over and over again. And then one of these points will be one of your answer choices here. So you need to take the slope they give you and do the same thing. Let me do another example. Let's say this is my slope, or this is my line. All right, here. And they say I have a slope of 4. Well, you might be thinking, well, 4 doesn't have a rise and a run. It just has one number. So what do I do about that? Well, you need to remember that all whole numbers can be rewritten as a fraction over 1. So then we are saying that my rise is 4 and my run is 1. And it's positive, so it's going to go up 4. Let me grab another color here. It's going to go up 4 over 1, and there's going to be a new point right there. And it's going to go up 4 over 1, another point right there. Up 4 over 1, another point right there. So these would all be the points. We have 0.32, we have 0.46, we have 0.59. So all of those would be points along the line that has a slope of 4. So that's how you would do that one. So remember, when it's a whole number or an integer, -2, it's over 1. So you see that? You can do that there. You remember what a slope of 0 means? Remember, a slope of 0 means that the line is... Stop. A slope of 0 means the line is straight across. I remember we already talked about one like this. And then we know what undefined means. The slope is straight up and down. That's what undefined means. So you'll use a line that goes straight up and down from that point. So what point would be along the undefined line going from this point? Well, that means this line is going to go straight up and down here. So which of these points below is going to be on this blue line going straight up and down? And that's pretty much it. So remember, you need to find the slope that they give you and count from the starting point. This was my starting point down here. Make that in a different color. Go from my starting point up 4 over 1 in this case, or as in my previous example, down 2 over 3, or whatever it is that they give you. And if you need graph paper, I would either recommend printing some out or whatever, but you can do most of these just by looking at the diagrams that they give you here. So that's it for this lesson, and stay tuned for lesson 6, and then we'll be done with this unit.